Welcome to the Animated Maths for All series. This is Series 2. Learn, grow, and excel with us. Welcome back to AniMath International School, where Monko makes math practice fun and engaging for everyone. Today, we will solve some volume of sphere problems with our friend Monko. As usual, we will do a step-by-step timed practice to reinforce our understanding of the concepts. Here is our first problem. A playground ball is a perfect sphere with a radius of 10 centimeters. Calculate the volume of air required to inflate it. Give your answer correct to 2 decimal places. We will use a precise value for pi, approximately 3.14159. Monko reminds us to follow the steps to find the volume. These steps include identifying the shape, extracting dimensions, standardizing units, applying the formula, and rounding the final answer. Let us draw a sketch first. Drawing a circle helps us visualize the sphere, clearly showing the 10 centimeters radius. The formula for the volume of a sphere is 4/3 pi r cubed. Substitute the radius, 10 centimeters, into the formula and use our precise value for pi to calculate the volume. Our calculation gives us a final volume of 4,188.7902 centimeters cubed. Now, do you think the answer is correct? Let's check the rounding requirement from the problem statement. Remember to follow all instructions carefully to ensure the accuracy of your final answer. The problem requires us to give the volume correct to 2 decimal places, so we need to round our calculated volume appropriately before giving the final answer. When rounded to 2 decimal places, the volume is 4,188.79 centimeters cubed. Well done, everyone. Excellent. It is 4,188.79 cm cubed. Let us find the volume of this hemispherical sphere of the same radius. We will use a precise value for pi, approximately 3.14159. Now we have a new problem to solve involving a hemisphere. How do you find the volume of this hemisphere now? One suggestion is that we should apply the formula directly. Another suggestion is that we can divide the previous answer by 2, since a hemisphere is half of a sphere, and the radius is same in both the cases. Both the approaches are correct. Yes, we can simply divide the previous answer by 2, as the radius remains the same. Calculate the volume now. We divide the volume of the sphere, 4,188.7902 centimeters cubed, by 2 to get the volume of the hemisphere. The volume of the hemispherical figure is 2,094.3951 centimeters cubed. Rounding to 2 decimal places, the volume of the hemisphere is 2,094.40 centimeters. If the radius of 1 lattice is 2.5 centimeters, what is the volume of 10 lattice in cubic meters? First, find the volume of 1 lattice using R equals 2.5 centimeters. We can use the calculator now. Substitute the radius equals 2.5 centimeters into the formula to find the volume in centimeters cubed. Now, we need to multiply this volume by 10 to find the total volume of 10 lattice. Multiplying the volume of 1 lattice by 10 gives us volume of 10 lattice. Dot. It's easy to multiply a decimal by 10. Move the decimal point 1 place to the right. The volume of the 10 lattice is 654.5 cubic cm. Monko says the answer is correct. What did he miss? We need to convert the cubic centimeters to cubic meters. Look at the board to learn. The radius is 2.5 centimeters, and we need the volume of 10 lattice in cubic meters. Our previous steps are correct. The students are laughing and saying Monko did not calculate the volume of his stomach.